Hi everyone, welcome to this latest episode in the building of a SFX-100 motion platform. In this video I'm going to go through dealing with the Arduino and building that up, loading the software onto it and putting the motor shield together ready to complete the electrical cabinet and all the wiring that I did in the last video, which is pretty much the last stage before I actually assemble the whole thing and try it out. So for this bit we need the Arduino Leonardo, which is listed in the bill of materials. I will put a link to where I got it from on Amazon in the description. Need a Pyroneus motor shield. I'll also put a link to I think it's on Race Department, where they have got together and done group purchases for this. This saves having to do all the wiring using a breadboard and the mess that goes along with that. Pyroneus has also designed this 3D printed housing for it all. I'll put a link to that in the description as well, and a link to his video where he talks about these things. Now the only modification I've had to make to this was that these little corners here were a bit sharp to actually fit in the sort of radius corners of the box. So I filed those down, and using a 2.5mm drill I've drilled out holes in the posts in here, and I've tapped the posts M3 because they use a M3 screw to fit these boards to this box. So I should just finish this last one, just in case anyone's interested and it's not in their field of experience. Threads are classed by diameter and by pitch. Pitch being the gap between the start of, the linear distance between the start of one helix and the next. So in this case it's M3 by 0.5mm. And to find the tapping drill that you need for a particular thread size, you essentially take the diameter, in this case 3mm, subtract the pitch 0.5mm, and that gives you your tapping drill. So in this case 2.5. Okay, so very straightforward, fitting the boards into this box. There are a couple of little design changes that I would do on this if I was doing it again, which I will run through in a moment. One is, I think I would, these posts that people put in these sort of boxes are never very strong and they tend to break. So as you see on this post here, it's away from that wall, which is not ideal for 3D printing anyway. So I would just run this blob and attach it to that wall. It makes it the post a whole lot stronger, and actually makes it a bit better for printing. And by the looks of things, this socket head cap screw that they've thought would fit nicely and attach this to the box, there's not enough room next to it for the head of the screw. But I think it'll be okay for, and I think I've got another one that will demonstrate the next point. These boards always have little bits of solder and stuff on the underside of the pins, which hold things off of these posts so they don't sit down properly. So I think I'd just try and take that into account with the design of the post or the positioning of the post, so that the board actually sits down properly. Small beans, but I'll point it out in case for your own build it makes a difference and that you can accommodate that change. So once the Leonardo's in, you can put the motor shield in and push the pins home into the Leonardo. And screw it down. The green little fitting here is for the e-stop, which is something I forgot to think about before I started this video. So that might be the subject of another one if I don't tag it on the end of this video. Okay. So that makes quite a nice, neat little unit. Okay, so to program the Arduino Leonardo with the software, you need to download the sketch file from Feedback's GitHub site, which you should probably be used to going to, because it's the same place as all the documentation is. So it's opensfx.com. Again, if things go quiet and I go to a captured screenshot, you'll know what's going on. It's just me trying to show you this clearer. Sim feedback, take you to the GitHub page and download the zip file, the sim feedback zip file. You need those. So actually, if we go back and extract it all, extract all. Okay, so the first thing we need to do is install the sim feedback software. And the way to do that, once you've extracted all the files, is you need to run this file called remove_blocking, and to run it as administrator. So it's Windows 10 in this case, is because I think it's because it's probably not got a recognised signature. It's prevented me from running it. So as you saw, I just pressed more and then say run anyway. Yes. Agree. So once that's done, you can run the sim feedback start application. And there we go. So the next thing we need to do is determine which COM port the Arduino is connected to. So all you need to do is plug in the USB lead that came with the board, connect that to a USB port on your computer, let Windows do what it's doing, just for clarity, just the USB. USB powers these boards, so you don't need a separate power supply for it. And then we need to find out what COM port it's on. So if we open Device Manager, and look at ports, we should see USB serial device. If I unplug it, it will disappear. So I know it'll come back, yep. So it's on COM4. We need to remember that. Right, okay, so once you know what COM port you're on, run scene feedback start again. You need to start this after you've plugged the Arduino in. Go to Setup, select which COM port it's on, COM port 4, firmware. In my case, downloads sim feedback, firmware. The first one, AC Servo Leonardo. And upload. And that's that. And that's that done. So I've decided that I will include a bit about the e-stop in this video. So actually one of the only things that isn't very well documented on the build of this is how to wire up the e-stop. Now, like I said earlier, in this Pyroneus shield, he's put a connector on the board so that you can wire the e-stop in. Only thing is I couldn't find is, or when I opened the e-stop itself, you've got 4 connectors, and obviously it's a 2-core wire, only 2 connectors on the shield board. So doing a bit of research, you've got 2 modes of operation for the e-stop, normally open and normally closed, and it would appear that the considered the best thing to do to have it wired up as normally closed, i.e. with the e-stop button released so that you push it to open the switch and cut the power, or cut the instruction to the actuators. So we need a bit of 2-core wire. I've still got some 3-core wire left over from wiring up the actuators, so I'm just going to use 2 of the cores out of that. I need to cut a hole in the e-stop to pass the wire into, and then feed the wire through the hole that's left in this box and to the e-stop, and I think it's as easy as that. Now, while I'm here, I shall mention another little improvement I think that we could put on this board. If we were to cut another window here, we could see the lights on the Leonardo, which might be helpful to know that the board's actually powered up. So I think I might do that. I might drill a hole in there just so I can see the lights, and I'll do that after I've gone and got some wire and put this e-stop in. So I've cut myself I think about 2 or 3 meters worth of cable, so that I've got room to put my e-stop somewhere convenient on the rig. Like I say, this is 3-core stuff left over from wiring up the electrical cabinet. And you only need 2 cores, but I'm just going to use the brown and blue for convenience on this. Because you're just breaking a circuit, you don't have to wire it up in any particular fashion. Just one core to one pin, and then to any pin in the normally closed side of the e-stop. Okay, so the normally closed side of the e-stop, designated here NC. So one of your cores go in one side, and the other one on the other side. Then I feed the wire through the hole. So we can close the box up. Screw it back together. Being careful not to do that. Popping up the nut from the other side, which is now probably going to be a pain to get back on. Yeah, so desperately try not to screw the nut out the back, because that's a pain. Putting that back in. Okay, so that's that end wired up. Right, so I've opened this hole up so I can get this cable in. I'm going to pare this back quite a long way so that I don't have to have all this cable in there, because I think it's going to affect closing the box lid. So I'll probably have it like that. So I'm going to pare this back. can't quite get this box lid down now with that cable in there like that. So just need to trim a little bit away. Fit now. There we go, wired up with the E-stop, and we are ready to put that in the electrical cabinet. Literally all we've got to do for that is I think screw it in with these 4 feet that we've got, and plug in the wires that go to the motor controllers, and then we can start playing with the actual full thing, seeing what it's like. Right, so that's the end of this video. Thanks for watching. Please like the video if you've enjoyed it. Please subscribe to the channel if you want to get automatic notifications when I do new videos. And until then, thanks for watching.